What are you doing?
Yes, I'm going to change this fuel oil sulfurs in the lubrication because we just we it change over let go to low sulfur.
Okay. Can you show me how to change this one?
Yes, of course. To change this one,
Okay.
you can go to cylinder lubrication.
Okay.
Then you click here.
Okay.
Yeah. Then you can reduce up and down.
Okay.
Yeah, whatever you want.
After
Okay,
adjusting,
then you can apply.
apply. Wait for a few seconds. What does it?
Yeah.
Okay. Applying now.
Okay, so by
Okay.
the way, I will tell you how to adjust the feed rate for cylinder oil. Because being the first engineer and chief engineer of vessel, you should understand about this one.
Okay.
Okay, let's start.
Okay.
First of all, I would like to make you familiarized with the items as the screens of cylinder lubrication, with description and functioning of each. Total cylinder oil is a flowmeter counter. Total cylinder oil consumption. This is the lubricating oil flow in liters per hour. Like to this one is LCD load chain dependence. This can be on or off, depends on the situations. Nominal feed rate, also called basic feed rate. This is product of feed rate factors and fuel oil sulfur contents. We will discuss more details this one later. About the part node control, as its name is defined to most of controlling the feed rates depending on whether the engine is running below or above the specified breakpoint. If the fuel index is above the breakpoint, it will be power mode. If it is below the breakpoint, it will be RPM mode. Feed rate factors. These parameters indicate the feed rate per percentage sulfur in fuel oil. These values is used for calculating the nominal feed rate. This setting values is determined based on the TBN number of the oil and total running hours of the engine versions and the condition of the cylinder nylers, and refers to the scrape down oils analysis. Okay, like is fuel oil sulfurs. Is sulfur content of fuel oil expressed in percent. This is a thing the operators have to update according to the fuel oil BDN or fuel oil analysis. Here we can see the breakpoint. As I mentioned about, this is the fuel oil index values at which the part load control will change to RPM or power mode. Please don't be confusing or misunderstood with the engine load. This value can be changed by the operator. However, as my experience with various versions of the ME engine, this is always setting at 40s, and for me, I never change this one. Okay guys, here we go, an example for breakpoint. Now fuel index 67%, and this is about the 40s, setting values 40s. So the engine part load controls is now at power mode. Okay guys, here is another example for the RPM mode. The fuel index is 33%. Then the part load controls working under RPM mode. Alright, Now we can talk about the minimum feed rate. This is for settings the minimum feed rate limit. The feed rate is not allowed to go below this limit to ensure that the cylinders receive the necessary lubrications. This value is also not subject to change unless you receive the instruction from the maker. Remove. This function is used for reducing wear when the engine has not been in use for extended periods. These functions can be turned on when the hydraulic pressure is available. So during preparation for the main engine, start turning gears. If you want to make some remove, you have to start the hydraulic pump manually, or you can turn the engine when the engine standby conditions with the main air run as the air reservoir to be closed. When you press the remove button, the system will make 12 injections of lubricating oils on each cylinders. And remember, remove cannot be activated when the engine is running. Okay guys, here we can see the running in indicated in gram per kilowatt hour. The buttons are used for the breaking in the running of the new liners and pistons or after the major overhauling of the piston. We will discuss this one later in the more details. Right about is the feed rate adjust factor. This is important thing to know that the operators often adjust this one to change the actual feed rate. The feed rate at each cylinder can be finely adjusted by clicking the corresponding buttons and entering a new adjust factors in the toolbar. Following this video, you will see how to calculate the feed rate adjust factors and how it's affected to the actual feed rate. The last one we need to be familiarized and understand is the actual feed rate calculated in gram per kilowatt hour. The actual feed rate indicating the required feed rate to be maintained for each cylinder. It's a combination of nominal feed rate adjust factors and feed rate factors. Okay, alright, you already familiar with some items, so now I will explain how to do the calculation of the feed rate. We have nominal feed rate, so-called the basic feed rate equal feed rate factors multiplied by fuel noise sulfurs. Here we have feed rate factors setting at 0.28 gram per kilowatt hour sulfur contents and fuel oil sulfur 2.32%. So using the above formula, we have 0.28 multiplied by 2.32 equals 0.6496. So it's same 0.65 at the nominal feed rate indicated upside. As you see, nominal feed rate depends on the fuel noise sulfurs and feed rate factors. The feed rate factors supposed not to change in the short terms, but the fuel noise sulfurs will be changed when you have new bunkerings. So for example, if we change from HFO to no sulfurs, the nominal feed rate also reducing. So in this case, we have to care about the minimum feed rate and please note between the minimum feed rate and nominal feed rate, whichever is higher, will be used. For example, if we have new bunkers with 2.0% of sulfurs, so we will have nominal feed rate equal 0.28 multiplied by 2.0 equal 0.56. So 0.56 smaller than 0.60. In such a case, the system will use minimum feed rate. Okay guys, that is our calculation by following the formulas and to understand between the nominal feed rate and minimum feed rate. So now let's see how it happens when we reduce the fuel noise sulfurs from 2.32% down to 2.0%. Okay, after we input the new values at the toolbars and apply it, the system will start changing. The nominal feed rate still calculated as 0.56, but the actual feed rate already calculated 0.60, exactly same with the minimum feed rate. Notice that here we setting the feed rate exact factors for all cylinders is 1.0, so the actual feed rate not affected by feed rate exact factors. Yeah, come back with the calculation formulas. We have actual feed rate equal nominal feed rate multiplied by feed rate exact factors. So we have 0.65 multiplied by 1.0 equal 0.65. So the actual feed rate following the formula, it should be 0.65. But why we see here the system is working at 0.81? This is because we also have LCD, load chain dependence. When load chain dependence is on, the system automatically adds 25% to the actual feed rate. LCD will be on or off if you select enable, automatically on or off. It is on when the engine is under load changing, for example under maneuvering or the adjusting of RPM. Then the load still not stable, the LCD will be on. However, if you disable this function, the LCD is always off. As you can see in the screen, the new values after added 25% will be 0.65 multiplied by 1.25 multiplied by 1.0 equal 0.8125. So exactly same with the indicators in the system. Okay, now I will try to reduce the feed rate exact factors of number 6. Let's see what happening. When I reduce the exact factors to 0.90, the actual feed rate of number 6 reduced to 0.60. Okay, we will try to analyze this why this number 6 working at 0.06. Okay, as formulas we have actual feed rate equal 0.65 multiplied by 0.90, so equal 0.585. In this case, minimum feed rate already used instead of nominal feed rate. So it means even you reduce the feed rate adjust factors to 0.8, 0.7 or lower, the system will be working at minimum feed rate and the cylinder will be protected. Okay, now we change to no sulfurs with 0.47 sulfur contents. You can see now LCD is still on, part loss control is power. As a calculation, nominal feed rate should be 1.3. But now the system working with 0.75 actual feed rate. So in this situation, minimum feed rate 0.60 to be used. Okay, so 0.60 to be used. Feed rate adjust factors 1.0. So it's supposed to be 0.60. But because LCD is on, so after 25%, then the actual feed rate becomes 0.75. For more information, when the part load control at power mode, the feed rate is proportional to the engine load. When the part load controls at RPM mode, the feed rate is proportional to RPM. In this case, the feed rate cannot be read on the graph. Okay, now we are going to discuss the last thing in this video, running in. How to use this one. This function will be used for break-in running or after overhauling. For example, here I need to set up this actual feed rate for the cylinders 1.3. So I will input direct 1.3 to the running in button. Okay, so to switch off this one, we just reduce this to 0. Okay, so I will not tell you how to determine these values because it's different from engine to engines, and you can find it in instruction manual. There's one important thing that never use this one if the engine is running in normal conditions, because when you use this one, this will override the feed rate adjust factors and set the actual feed rate equal to the running in feed rate specified by the operators. It means the actual feed rate will not change at any condition, not depends on the RPM or load, but it fixes the values when you input for running in. I found this one in the internet and I see it's very dangerous. On board ships, sometimes I share what I know to my crews. First thing, if you want to change this feed rate for cylinder white, you can adjust it from here. Feed rate adjust factor. For example, you want to increase 1.13. Okay, you have to drive only one cylinder. Then it's going here.
This one will go here.
Yeah, there's something going here. 1.13. So basically, if you want to adjust this cylinder individual, you adjust this one individual cylinder. So you adjust this one for individual. But if you want to adjust for all, you want to adjust for all the cylinder. Back first. If you want to adjust for all the cylinder, you have to adjust this feed rate factor.
In the feed rate
Yeah.
control.
Because basically this nominal feed rate equal to basic factor, feed rate factor sulfur content. You can try. Yeah. 0 to 8 0.7. How much? 0.13. Yeah. 0.13. Yeah, nominal feed rate. So if you want to change old cylinder, you apply new feed rate. Yeah. Otherwise, if you keep the feed rate, you will change the fuel moisture curve. This fuel moisture curve depends on your bunkering, so you need to change it. So if you want to adjust, you adjust this factor. However, this one they have another actual feed rate. Actual feed rate. Actual feed rate should be adjust factor times nominal feed rate. Yeah, so 1.1, 1.0 times 0.13. It should be 1013 here. But very left, that is 1. So the system will working with only minimum feed rate.
0.60.
Yeah, 0601. Because now you cannot see people nowadays. So that's why if people asking you how to adjust the feed rate, the oil, you adjust the feed rate factor for individual cylinder. If you want to adjust for own cylinder, you adjust the factor here. So this will change this nominal feed rate. The nominal feed rate change. This will come with this factor become actual feed rate. So you know something.
Thank you very much for the information, Chief.